This is Dijkstra algorithm, very important algorithm to determine the shortest path. Shortest path for weighted graph. Without weighted graph, we can calculate simply only edges. Number of edges we have visited to source to last destination. So once axiom 1, every vertex j which is not yet permanently labeled gets a new temporary label. So first you remember this permanent label, we give only the initial vertex. Initial vertex we start visiting from vertex A, that means we give the permanent label at 0. Otherwise we give all the vertex as a temporary label infinity. Temporary label infinity. Infinity means we can say that the distance from A to B is infinite, A to C and A to D, etc. So we just give the infinity accordingly and follow this axiom. That means we have used this formula: minimum of old vertex of J, J be any vertex, every vertex J which is not yet permanently. That means which is not yet permanently labeled get a new temporary label by using this formula. So axiom 2 is smallest labeled among all the temporary labels. So we find the smallest labeled among all the temporary labels. Then we give the permanent label of that vertex. Then in case of tie, that means two vertices have the same value. So we can take any one of them and give the of that vertex, permanent label of that vertex. And we repeat this axiom 1 and 2. Alternatively, we reach to the destination vertex, destination level. So that means other purpose is that to give the permanent level all the vertices. When we reach the destination, so then all vertex gets the permanent level. Okay, so we start with one problem, so you can understand Dijkstra algorithm by the problem. Okay, so note down the problem. Problem related to Dijkstra algorithm. Dijkstra algorithm. Dijkstra algorithm to find the shortest path, between vertices A and F. In the given graph is given, this is the vertex A and this is the vertex B, this is the vertex C and this is another vertex. So this is the vertex A, this is vertex B, C, and this is the vertex F, destination vertex F. This is vertex D and E. Each as having some weight. The vertex that means the as AB having weight 3, this having weight 1, this having weight 7, and this as having weight 6, this as having weight 3, this as weight 1, this as having weight 4, 3, 2, and 6. So this is the graph. So we calculate the shortest path from A to F. Shortest path from vertex A to vertex F. That means this is our source vertex, we start visiting, and destination vertex is F. So we calculate the shortest path from vertex A to vertex F by using the Dijkstra algorithm. By using the Dijkstra algorithm. Okay, all you noted? That means notice this question. Payal, Mashar, Mukesh. Okay. So now we start using the Dijkstra algorithm. That means solution of the problem by using Dijkstra algorithm. So we write as, that means this is our initial of Dijkstra algorithm. So the algorithm start by assigning a permanent level 0 to the starting vertex. So we assign a level 0 to the starting vertex and a temporary level to the other vertices. So just we construct a table. So the initial level you write as the initial level is given by, you write as first is vertex, second level of each vertex we denoted as LV, level of the vertex, and third one is the set S, you can denote S or you can denote T, set of the vertices. So that means vertex, first we write as vertex A, vertex B, vertex C, vertex D, vertex E, and vertex F. So here we use 6 vertices corresponding the leveling of the each vertex. So that means we start visiting from vertex A. So give the permanent level at that vertex. So the permanent level is 0, 0 to the vertex A, and leveling to the other vertex is temporary level is infinity. Temporary level is infinity. So give the temporary level to other vertices is infinity. Okay, and T be the set of vertices. Set of vertices, that means you write in the set form A, B, C, D, E, F. Just write in set form or curly bracket. So this is the set of vertices. So we use this table in each step. Now we use the axiom 1 and axiom 2. So we denoted as iteration. Axiom 1, because we write as we repeat a step again and again until we get to the destination, give the permanent level to the all vertices. So we start with iterations. Number of iteration, that means iteration 1. So this is our iteration 1. So we write let u, small u, which equal to a. That means initial vertex. So we give the initial vertex as a, u equal to a, has level, that means level of vertex A. What is the level of vertex A? Which is 0. And T becomes the set T having all vertices. T becomes, that means when we give the permanent level to vertex A, then T becomes T minus A. T minus A. So when we give the permanent level to any vertex, so then we remove that vertex from the set of vertices. So we write as T minus A. We see that how many edges or how many vertices incident with that. So we see that from vertex A to vertex B, that means one edge from vertex A to B and a vertex D from A. So there are two edges. So we write as there are two edges incident with vertex A. So there are two edges incident with vertex A. two edges incident with vertex A. So these are the two edges, that means as this one AB and AD. So two edges AB and AD are incident with vertex A. We write in bracket as AB and AD. So there are two edges incident with vertex A, AB and AD. Understand? So first we give the permanent level to the starting vertex, that means permanent level is 0. And next step, that means we see that how many edges incident with that vertex. So we see that there are two edges, that means this edge and this edge incident with that vertex. So we write as AD, AB and AD incident with vertex A. So we write B and D. We see that B and D where we see that B and D both are belongs to set T. B and D both belongs to set T. So now we use this formula. Now we use the formula. This is our formula. So for to give the temporary level, that means as minimum of old level of J, comma old level of I plus weight of Ij. Ij means I is the initial vertex and J is the next vertex which is incident to the I. So you can understand this. So we write as level. That means we see that there are two vertices which are connected with A, that means vertex B and vertex D. So for finding the leveling of vertex B and vertex D, so now we write the leveling of vertex D. So when you write the leveling of vertex B, so how to write the leveling of vertex B? We use the formula which is minimum of old old level of J. J means next vertex. We are talking about Ij. I is the initial vertex, J is the next vertex. So here B used as J. So old level of B. That means we can use as uh, that is you can use as old level of B. Old level of B, comma. Old level of B, comma. Next, old level of I. Old level of I. Level of I means A. Old level of A plus weight of AB. Weight of Ij. Ij means AB. Weight of AB. So you can write as minimum of old level of B. So we give the old level B as infinity. Old level of B is infinity. Here we see that the old level of B is infinity, comma old level of A. Old level of A is 0. That means A give the permanent level as 0 plus weight of AB. Weight of AB which is 3. Weight of AB, that means as AB is 3. So which is 3. So you can write as this equal to minimum of infinity comma 3. So what is the minimum value? Minimum value is 3. So level of B is 3. Level of B is equal to 3. So this is the level of B is equal to 3. Similarly, we find for level D, because D is also incident with A. So we find the level of D. So same formula we use, minimum of old level of D, comma old level of A plus weight of AD. Weight of AD. W represent for weight. So this can be written as minimum of old level of D is infinity Old level of A is 0 plus weight of AD. What is the weight of AD? Is 7. The weight of AD is 7. Weight of AD is 7. So this equal to, we can write as infinity into 7. So what is the minimum value? Minimum value is 7. So this equal to 7. So the level of D is equal to 7. So we determine the level of both the vertices, that means vertices B and vertices D. So level of D equal to 7, level of B is equal to 3. So we draw same table, that means next vertex A, B, C, D, E and F, and corresponding write the level of each vertex, and here we write the T. T means set of the vertices. So level of A is 0, permanent level. We find the 3, C infinity, D 7, E infinity, F infinity. And we give the permanent level to the vertex A. So then we eliminate vertex A from the set of vertices T. So we start with V, C, D, E and F. So once we give the permanent level to any vertex, then we remove from the set of vertices. So we write only B, C, D, E and F. Now we see that the minimum level of the vertex. So here minimum level is level of B equal to 3. Once we give the minimum level to A, so we do not check the A, that means we check only the level of B and D, because both have the level 3 and 7. So because we want to give the permanent level to that vertex, so in both we have to check the minimum level again. So vertex V and D having level 3 and 7, so we count the minimum level of both vertex. So that means minimum level, this is 3. Minimum level, this is 3 having vertex B. So now we give the permanent level. We give the permanent level to the vertex B. We give the permanent level to the vertex B. Now we move for the iteration second. If you have any doubt, you can ask. So this is our formula for finding minimum level. That means we initially U equal to A we consider. That means we start with the vertex A. So U equal to A, and the level A we give the permanent level as 0, and we eliminate from A T minus A. So we in this table we write down starting with V. We cannot use A, because once we give the permanent level to any vertex, then we eliminate from the set. And the two vertices A and V and D, which are incident with vertex A. So we find out the minimum level of both vertices B and D, and vertex level of B is 3 and the level of D is 7. So we write 3 and 7 in the table. So again we check the minimum level of both vertex. The minimum level of both vertex. So we see that level B have the minimum weight, which is 3. So next vertex, so that means next iteration 2. For iteration 2, we select U is equal to B. Here we select as U equal to A, but now we select U equal to B, because we give the minimum level of B is 3. So we take U equal to B. and LV we write as LV low level of B, which is equal to 3. So we write as T becomes now T becomes is T minus B. T minus B. So we eliminate B from the next table. So we see that how many edges incident with the vertex B? How many edges? So that means we see that BC, BD and BE. There are three edges incident with vertex B. So you write as, so there are three edges. Three edges, that means BC, BC, BD and BE. Three edges we write as BC, BD, BE. Incident with vertex B. With vertex B. Or we see that C, D and E both belongs to the T. That means we construct the table. So we see that C, D and E all belongs to the T. Now we check the minimum level of vertex D again. That again means we once we have checked here, but now we also check the minimum level of vertex D. So now vertex D and vertex C and vertex E for all three. So we start with the C, no issue. So we start with C. So this equal to minimum of, you remember the formula, minimum of old level of vertex B, old level of vertex B, comma, and level of vertex C, we write as old level of vertex B, old level of vertex B, old level of vertex B for finding C. So here we write old level of vertex C. So this is for C, old level of vertex C, and now we write the old level of vertex B plus weight of BC. Old level of vertex B plus weight of BC. That means level of vertex D. So you can write minimum of old level of C. Old level of C is infinity, and the old level of B is 3. Now we check this table only. So the level of B is 3 plus weight of BC. Weight of BC. What is the weight of BC? BC is 6. Weight of BC is 6. Weight of BC is 6. So this equal to minimum of infinity into 9. This equal to 9. So the level of C is 9. Now we again calculate level of D. So level of D, minimum of old level of D and old level of B plus weight of BD. So minimum of old level of D. Now we check the old level of D. Here old level of D is 7. Old level of D is 7. So now we write the 7, comma, old level of B. Old level of B is 3 plus weight of BD. What is the weight of BD? BD weight is 1. So weight of BD is 1. So this equal to minimum of 7 comma 4. So this equal to minimum is 4. So now new level of D is 4. Same we calculate for level of E. So for level of E, minimum of old level of E, comma, old level of B plus weight of BE. So this equal to minimum of old level of E is infinity and old level of B is 3 plus weight of BE. What is the weight of BE? BE is 3. So weight of BE, this equal to 3. So this we can write as minimum of infinity into 6. So this equal to 6. So level of E is equal to 6. So the level of E is 6, level of D is 4, and the level of C is 9. Level of C is 9. Level of C is 9. Now we draw again a table. So for drawing the table, we write as vertex, level of vertex V, and a set of T. So once we give the permanent level to the vertex A and B, so we do not write in set T. So here we write as A, B, C, D, E, and F. The permanent level of A is 0, level of B is 3. Now we calculate the level of C. So we write the new levels. That means level of C is 9, level of C is 9, level of D is 4, level of E is 6, and level of F is infinity. And here we do not write A, B, so we start with C, D, E, and F, because both vertex A and B have the permanent level. Now we check these three vertices. That means vertex C, vertex D, vertex E. Which vertex have the minimum level? Which vertex have the minimum level? So here we write as here the minimum level of vertex B, vertex D is equal to 4. Vertex D is equal to 4. So this is the minimum level. So now we give the permanent level to the vertex D. We give the permanent level to the vertex D. So we start with the iteration number 3. Iteration number 3. So iteration number 3, that is U equal to write as D, has level of D is equal to 4. Then T becomes T minus D. T becomes T minus D. Now we see that how many edges incident with vertex D. How many edges incident with vertex D? So there are 2 edges. That means D to C and D to E. Because we do not give the level yet to the vertex C and E. So now because we give the permanent level to A and B, so we do not write for A, B, just we write for C and E. So there are 2 edges. We write as there are 2 edges incident with the vertex D, that is DC, DE, where C and E both belongs to T. So we calculate the minimum weight, that means level of C. So we write as minimum of old level of C, comma, old level of D plus weight of DC. So this equal to minimum of old level of C. What is the old level of C? Here we check the table. Old level of C is 9. Old level of C 9. Old level of D is 4 plus weight of DC. What is the weight of DC? We check the this figure. So the weight of DC is 1. Weight of DC is 1. So we write as weight of DC is equal to 1. So this equal to minimum of 9 comma 5. So this equal to 5. So level of C. C gets a new level again. So the minimum that means level of C which is equal to 5. Now we calculate the level of E. Level of E is equal to minimum of old level of E comma old level of D because E and C are incident with the D. So for yeah, here we write D and E plus weight of DE, weight of DE. So this equal to minimum of old level of E. What is the old level of E? Old level of E is 6. So old level of E is 6 and old level of D. Old level of D is 4 plus. What is the weight of DE? Weight of DE. Weight of DE is 4. Weight of DE is 4. Weight of DE is 4. So this equal to minimum of 6 comma 8. So this equal to 6. So the level of E, new level of E is 6. New level of E 6. So we see that the previous level was also 6 and this level is also 6. So no issue. Now we construct the new table. So we construct the new table vertex, level of vertex and the T set of. So we write as A, B, C, D, E and F. So this having level 3, this vertex, this vertex having level 0, this having 3 and we give this permanent level to the D. That means this is 4 and new level of C. New level of C is 5. New level of E is 6 and F having infinity. And the remaining vertices, so because we give the permanent level to the vertex A, B and D, so we write as C, we write as E and F. So T basically represent this, that means how many vertices are remaining to give the permanent level. How many vertex are remaining to give the permanent level. Now we determine the leveling of C and E. So we have to check the minimum level, which vertex have the minimum level. So minimum level vertex is C, that means which is 5. So here the minimum level which is C is equal to 5. The vertex C which is equal to 5. So we write as iteration, next iteration number 4. Here U denoted as C, so has a level that we see is equal to 5. So we write as T becomes T minus C, that means we eliminate C from T in next step. So there are how many edges incident with C? That means C to E and C to F. because we give the permanent level to the vertex A, vertex B, and vertex C. So there are two edges. There are two edges incident with vertex C, that is CF and CE. So E and F we write as where belongs to the T. E and F here also belongs to the T. We see that E and F also belongs to the T. This is for new T. That means previous table, this table. So we find out the leveling of vertex E. So leveling of vertex E, minimum of old level of vertex E, comma, old level of vertex C plus weight of CE, weight of CE. So this equal to minimum of old level of E. What is the old level of E? Old level of E is 6. So this is the old level E 6, comma, old level of C, C is 5. Old level of C is 5 plus weight of CE. What is the weight of CE? Weight of C is 2. Weight of CE is 2. So we write as 2. So this equal to minimum of 6, comma 7. So this equal to 6. So LE having new level which is 6. So LE equal to 6. LE equal to 6. Now we find out leveling for F. So we write as minimum of old level of F, comma, old level of C plus weight of CF, weight of CF. So this equal to minimum of old level of F. What is the old level of F? Infinity. Old level of C 5 plus weight of CF. What is the weight of CF? Weight of CF is 6. Weight of CF is 6. So we write here is 6. So this is a minimum of infinity into 11. So this is 11. So level of F is equal to 11. Level of F is equal to 11. Now we construct again a table. So for vertex, level of the vertex and T. So A, B, C, D, E and F. The leveling 0, 3, 4, 5 and now C. E having level, F having a level 11. So in set of T we write only two vertices. This is E and F are remaining to get the permanent level. Only E and F are remaining to get the permanent level. So this is our new table. So here we see that the minimum level which is LE equal to 6. Minimum level which is LE equal to 6. So we see that iteration 5, iteration number 5, U equal to E, U equal to E. Level of E is equal to 6. So we write as T becomes T minus E. T becomes T minus E. So there are That means remaining one edge only. There are only one edge incident with E. That is EF. That is EF. Here F is also a member of T. Here this one, this F is also member of T. So now we calculate the level of F. That means only one vertex are remaining to get the level. So level of F is equal to minimum of old level of F, comma old level of E plus weight of EF, weight of EF. So this equal to minimum of old level of F is 11. You see that 11, and plus old level of E is 6 plus weight of EF. What is the weight of EF? The weight of EF is 3. Weight of EF is 3. So weight of EF is 3. So this equal to minimum of 11 into 9. So gives us 9. So that means level of F is equal to 9. Okay. So we construct again the table. That means vertex, level of vertex B, A, B, C, D, E, and F. This having 0, this having 3, this having 4, this having 5, this having 6, and this also having 9. And remaining vertices in T. So no vertex remaining in T. That means only simple we gave the F. That F also get the F is the final vertex, last vertex. So F is the last vertex. So this F is the last vertex. So there is no iterations are remaining. Minimum level is LF. LF equal to 9. So U equal to F. That means U equal to F. So we stop because we have no choice. Stop the iterations because F is the final vertex. So shortest between shortest vertex, shortest distance. So the shortest distance between A to F is 9. So this 9. So A to F is 9. So we write the shortest distance. This A to F is 9, and the shortest path. So you write the shortest path. So with shortest path having distance 9, so you can check from the graph. So B, E, and F 3, 3, 6, 3, 9. A, B, E, F. So shortest path which having distance 9, so you can write as A to B, B to E, and E to F. So this is the shortest path. So this is the Dijkstra algorithm. So hope you understand this algorithm. We repeat the same step again and again, give the permanent level to the vertex, and we reach to the end vertex, that means destination vertex F, to give the permanent level and find the shortest path. Okay. You got it, Ankita, Dipanshi? So thank you, students.